Hello guys, hope you're doing well, and as always, if you are new to my channel, I would request you to subscribe to my channel so that you shall be able to watch all my related engineering videos. Thank you. All right, the problem at our hand is that we are going to deal with a friction problem, and here basically we are being given a 45 kilogram disc which is resting on the surface, for which the coefficient of static friction is mu a is equals to 0.15, which is means at this point the couple moment is given as m equals to 50 newton meter. This is our couple moment, 50 newton meter, and we need to calculate the friction force at A. What is the friction force which is being generated at this point? Basically, we have to calculate the friction point at this A. Okay, so if you because of the motion, the friction force will be basically acting in the negative x-axis. Okay, so what we will do to solve this problem is, first of all, we have to understand whether this problem corresponds to type 1 problem, type 2 problem, or type 3 problem. Okay, so what we will do is basically we will break up into two components, two subsystems of this system, which is in which we have one bar, and in the other we have a circular disc. Okay, so what we will do, if we break up this bar, it is basically here it is. Okay, this bar B is connected with a pin support here with the disc, so will be two reaction components, and this bar at C is also being connected with a pin connection, so there are two components, Cx and Cy, and we know that the horizontal distance from C to B is 300 millimeters, so we say 0.3 meters. Okay, when we go for the disk, you see at the point B, again there is a pin connection, so we have Bx and By as the reactions. Make sure that the reactions here are basically opposite to point here what you assumed. Okay, Bx is along the positive negative x, so here it is positive. By is along positive y, here it is negative y. The very important point A, if you look at it, the normal reaction is perpendicular to the surface at the point of contact, which is Na. The frictional force over here is basically, since the motion will be in the uh, anti-clockwise direction, so the friction force is basically acting towards the negative x-axis. Okay, we assume, and the weight of this disc as given to us is 45 kg, so it will be at point O. At point O at the center, it is 45 into 9.81. So this is about the explanation of the free body diagrams of A and B. So we check for type 1, type 2 and type 3 problems, and we see that in the type 1 problem we can easily deduce that the number of equations is equals to number of unknowns is equals to number of equations of equilibrium. So if we look at the number of unknowns for this system, is basically, you can say, 1, 2, 3, 4. These are the four unknowns. Plus, when we go for the second disk case, we see one unknown as Na and one unknown is Fa. So 1, 2, 3, 4, 5, 6. So there are basically number of unknowns are 6. 1, 2, 3, 4, 5, 6 unknowns. And how many equations of equilibrium we have? We have three equations of equilibrium for the bar, and we have the three equations of equilibrium for the disk. So we can easily say that this 3 plus 3 equations of equilibrium will be equals to 6, and the number of unknowns for this system is also 6. Since the left hand side is equals to right hand side, we have already studied in the theory that it will be a type 1 case problem. If you would have not understand what is type 1, type 2, type 3 problem, you refer to my friction playlist and see the type 1, type 2 and type 3 case problems for the friction. How do basically decide it is a type 1 problem, type 2 problem, or a type 3 problem. Okay, so now we concentrate on the free body diagram of A, which is this one. Okay, we say that if we sum all the moments at C, we will get By into zero point 0.3, and we will get Bx into zero point 0.4, and if you look at it, both Bx and By will be nothing but clockwise movements, so minus sign comes. And we also know there is a couple moment which is 50 Newton meter, which the couple moment never gets zero, because it is a couple moment, it is a free vector, so we put 50 Newton meter here. This is a very important A equation. Then we apply sigma fx on this. We say that minus bx plus cx equals to 0, so we can say bx equals to cx. We apply sigma Fy to this bar. We say plus By minus Cy equal to 0. So again By equals to Cy. Okay, now you go for the free body diagram B, which is this one, the disk. Okay, and if you look at the free body diagram of the disk, as already explained to you, if we apply sigma fx equal to 0, where you will get this component positive bx and minus fa will be equal because it will be plus bx minus fa equal to 0. So bx will be equals to fa. This is our equation number 3. Okay, so once this is being done, we have equation 1, equation 2, equation 3, and we have this as the equation A. Okay, so once this has been decided, now we basically go to basically a free body diagram B, further explanation. Okay, so for the B, we apply sigma Fy equal to 0. When we apply sigma Fy equal to 0 for this problem, we get Na minus By minus 45 into 9.81. Okay, so Na and By, and this is the weight of the disk. Okay, Na minus By, if you go previously here, if you look at it, this Na is basically towards the positive y. Okay, and the weight is basically acting in the negative y, and the By is also acting in the negative y. Okay, so that is why they say positive Na minus By minus 45 into 9.81 is equals to 0. Now you apply summation of moments at O equals to 0, which means you apply the moment summation at this center point of the disk, exactly at this point. So when you apply this, you get By into 0.125 minus Fa into 0.125. Okay. So how you do it? Again, if you look at it, this will be the diameter of this disk as given to us is basically the radius is 0.125, diameter is going to be 250 millimeters, which is 0.25, which is 2.250 per meter. Okay, so the radius is going to be 0.125. So if you look at it over here, as they have explained, By into 0.125 minus Fa into 0.125. So this is By into 0.125, and this Fa again will be, or its radius will be Fa into 0.125. So as explained here, we calculated it, and basically movement is taking anti-clockwise. So we get another equation as By is equals to Fa. Now from the equation A, as explained to us, from the equation A that we have previously developed over here, this was our equation A minus By into 0.3 minus Bx into 0.4 plus 50. Uh, we get this equation. From this equation we know that By is equals to Fy, By equals to Fa, and we also know that Bx is also equals to Fa. Remember, here basically we have decided over here that Bx is equals to Fa. So with this knowledge of equations, we can say to this equation is basically By is equals to Fa and Bx equals to Fa. So in place of By we put minus Fa into 0.3, and for Bx we put minus Bx equals to Fa. So here we put minus Fa into 0.4 plus 50 equals to 0. So we have the entire equation in Fa. Okay, we can add zero point 0.4 and zero point 0.3, we get minus Fa 0.7 equals to minus 50. So we get a very important relation that Fa is equals to 71.42 Newton. Now we have calculated Fa. Now we are also interested to, we know that from the equation 4 that By is equals to Fa. Remember, we know it is By is equals to Fa. Here it is. Okay, we know. So we can basically put the value here as Na minus, and for By, here for By we can put Fa, because By equals to Fa. So here we can put uh, for By we can put minus Fa, minus 45 into 9.81 equals to 0. And now we also know that Na minus Fa equals to 45 into 9.81 is 441.45 Newton. This minus Fa, if taken on the other side, it will be Na is equals to 441.45 plus Fa. But what is basically Fa? We have basically just calculated our Fa as 71.42 Newton. So basically, when we put a value over here, we get Na equals to 512.88 Newton. So we have calculated our Fa and we have calculated our Na. Now we have to deduce our results. We know, since it is a type 1 case, so Fa max equals to point mu A into Na. Mu A is 0.15 and this Na we have just calculated, which is 5112.9, which is equals to 76.93 Newton. So the maximum friction force at the point A will be 76.93 Newton. If our our force, that is basically, if you look at it here, if this force, this Fa force exceeds the maximum force, then the disc will slip. Okay, so basically we know the main condition over here, it has to be lesser than the maximum friction force. So our maximum friction force come out to be 76.93 Newton, and our Fa that we calculated was 71.4 Newton. And since the maximum friction force is much higher than the friction force at A, so we can easily conclude that there is no motion in the disk. Okay, just for knowledge, if this Fa, for example, you calculate and for example comes out to be 80 Newton. Okay, if it comes out to be 80 Newton here and maximum friction is basically 76 or 77, then we cannot solve this problem with type 1. We have to refer to type 2 or type 3 problems. But over here, we are doing according to the rules, that since maximum friction is higher than the friction at point A, so we can say there will be no motion in the disk. So it is a very good problem. So I have decided to solve this problem for you guys. I hope you have a wonderful day and thank you very much.